Hello friends, welcome to Java threading tutorial. In this video we will learn about Thread.join. So here we will use a thread that extends from thread class. Then we will allow the main thread to wait for the child thread to complete. So this way we will see what is the role of Thread.join. A running thread can call other threads join method. So, for example, let us say thread A and thread B started doing a task. So here there are two threads and they are doing their job. So the threads are thread A as well as thread B. So thread A can call b.join because there are two threads, right? One is A and another one is B. If thread A wants to wait for B, it can make a call to join. So it should call that on thread B's thread B.join. So thread A will wait for thread B. So here in the above scenario, thread A is making call to join method on thread B. That means thread A waits for thread B to complete. Let's state that main thread is running. When it is running, it spanned one more thread. So here, if you see, main thread is spanning this thread. So the thread is running here. And let's assume that it completes the task at some stage. Let's also state that main thread is spanning one more thread. So here, if you see, there are three threads. One is the main thread and another one is child thread, thread A and thread B. So they both are, all three threads are running in parallel. And here if you see, thread B finish first. So if this is the time span, right? And you can see thread B is finishing first here on the timeline. Then thread A is finishing. Finally, main thread is finishing. Suppose if we want main thread to wait for thread A, then main thread towards the end, instead of ending like this, it can make call to a.join. So if that's the case, then thread B will not end and it will be in the suspended state and it will wait for thread A to complete. So once thread A completes, thread B will join with thread A and both will finish together. So that's the use of join method. Here if you see, thread B towards the end is making call to a.join. So that means here thread B want to wait for thread A to complete. So here is the waiting period. The actual end time is here. And if you see, this is the wait period for thread B because thread A is running right here. So once thread A finishes, thread B also will finish and they both come out together. Let's explore this with an example. So here you can see we create a class called Thread.join ex03 Thread.join that extends from thread. and inside the constructor we set name for the thread, and then we are starting the thread. Since our ex03 example extends from thread, when you make a call to start method, it will expect the run override, and in the run override, if you see, so this will run in the thread context, and we have a loop that runs from 1 to 9, right? And this is a thread actually, so thread will run for 9 times, or it will loop 9 times in the for loop, and each time we get name for the thread, which was already set here using the super.name, right? It prints that thread name. Then it also prints the loop counter. Then we are making this thread to sleep for 350 milliseconds. So that's what we are doing. So it will print number 1 to 9, and for each print it will wait for 350 milliseconds. Then here is our main program entry. That means here we have the main thread, right? So we are creating instance of our threaded class, and we are naming it as child, and in the constructor itself we are making call to start. So once you create the instance of our thread, we know that the thread will get started and it will make a loop for 9 times, and each loop takes 350 milliseconds, and with a 350 milliseconds delay it will print message 1 to 9. So all this stuff happens at this line itself. Since it's a threaded one, after starting this thread, the main will come to next line and start executing it. So from this point itself, there is a thread that is running in parallel, and main also running in parallel here. And in the main, if you see, after printing the starting main thread, we run a loop for 9 times here as well. The only difference is here it runs for 200 milliseconds. So the loop counter is the same for main as well as child thread, but delay is different. So the main thread also printing the counter 1 to 9. So here main thread 1, likewise it will go up to 9. So towards the end of this loop, or after ending the loop, here we purposefully commented this, and if you see thread child, we are holding a handle for the child thread. Here we are making call to join. So who is calling this? The main thread is calling this, right? This is the main thread, right? The main thread is calling join on the child thread. That means main thread will wait for child thread to complete. So once a child thread completes, you will see main thread quits. So here starting main thread, printing 10 numbers. After that we are printing main thread quits. And let's state that this is the time interval. So we know that main thread starts here, and let's state that it completed printing 9 here, and at a different interval it printed other numbers, right? So this is the time span of main thread, and if you see the interval or print interval here is 200 milliseconds. We also know that the main thread spans a child thread. So here it is spanning a child thread, and child thread also runs in parallel. So it also printing the number at a periodic interval, and here it is 200 millisecond, and here it is 350 millisecond. I mean, child thread takes 350 millisecond to print each numbers, right? So definitely, even though main thread is starting the child thread, main thread still goes, it will not wait, and both will run in parallel, and the main thread complete quickly printing all the 9 numbers because the delay here is only 200 millisecond. But child thread will keep on running, and it prints the numbers with a higher delay, 350 millisecond. So if you don't want to quit the main thread, you have to make a call to join. So the moment you make join, the main thread will not exit, and the program will still run, or it will be in the waiting stage. And once it sees child thread completed, the main will end. So that's why the main thread is making call to join towards the end. So it is making call to join on this specific thread. That's why here you see thread child, which we created here, thread child dot join. So we will create a new class, and we will name it as ex03 thread join. We will extend this class from thread class. So Java lang is a default package, so we can even remove this. So we will provide a constructor. So here is our constructor, and constructor is taking a name, and we are making call to super. Super means thread class constructor, and we are setting the name. After that, we are making call to start. We know that since it's a thread class, it will expect a run override. So this is the one we want to override. So in the body of the run method, we will run a loop, and the loop run for 9 times since we are starting it from 1, and it prints a message and have a sleep of 350 milliseconds. So we created our thread class. We have a run method that run for 9 times with a sleep of 350 milliseconds. After that, the thread quits normally. So this is the body of a for loop, right? After printing all the numbers, it will come out. Now let's go to the main entry and we will create a driver code. We will remove all the main function content from our previous example, and we will experiment the code for this one, for this example. Alright, so we already explained this in the slide. We are creating an instance of our child thread, printing a message before starting the thread and before quitting the thread. Right inside, if you see, we are running the main thread for 10 times with a lesser sleep second to 200 millisecond here, and child thread takes 350 millisecond. For the first time when we are running it, we are not making call to join and see what happens. So now we will have more window here. Clear the console and we will run it. And if you see, both main thread as well as child thread printing the message in the console window. So starting main thread, and when main thread is starting, here you are seeing starting main thread, right? That got printed starting main thread. It enters the loop, and before printing this message, if you see, it already started the child thread, right? That's why starting main thread and you see child one, because here if you see, this is the main thread. Main thread already started the child thread and it printed a message called starting main thread. Before it prints main thread sequence number, child thread printed its content. And you can see the race is going on between main thread as well as child thread. Main thread is printing 0, main thread is printing 1 and 2. Alright, when you move down, you will see that child thread is still continuing, and at one point you will be seeing that main thread quits and child thread is still continuing. That means main thread is not waiting for all the child thread, or here we have only one child. Main thread is not waiting for the child thread to finish its job. If you look at the code, we have main thread quits as the last line of statement, but still some piece of code is running and printing the content, and this is coming from the child thread. Right, even after main thread quits, there is a 350-second delay, right? So child thread is still running here. Now we will make a simple adjustment of main thread waiting for the child thread to finish. Now this time if we run, if you see, main thread quits comes after the child thread quits, right? You can even put some statement towards the end of the for loop. Now let's run this. and you will see child quits. After that, main thread quits. Right? That's the use of thread.join. Here, main thread is stating that I will wait and I will join with the child thread by making call to join. Likewise, it can even join multiple thread so that it here in the sense main thread can wait for all other thread to finish its job. That's all here in this video. Thank you for watching. Bye.